Hello friends, in this video we are going to discuss about a numerical on drift velocity and scattering time. So in this numerical we can see for a sample of gallium arsenide the scattering time is given by tau sc equals to 10 to the power minus 15 second, and the effective mass of the electron is given by 0.076 m0, and we know that the effective mass of the electron is denoted by Mn. Now if an electric field of 10 kilovolt per centimeter is applied, then the drift velocity is produced dash into 10 to the power 6 centimeter per second. We have to find the drift velocity. So drift velocity is denoted by V suffix d, and this is the applied electric field. So we have to find this drift velocity. So from this question we know that we need to find the drift velocity, and the drift velocity equation we know that it is given by q into tau sc into capital E divided by Mn, where q value is 1.6 into 10 to the power minus 19 coulomb, and E value is given in this question as 100 kilovolt per centimeter, and Mn value, that is the effective mass of the electron, that is given by 0.076 into m0, where this m0 value is the rest mass of the silicon, rest mass of electron, and it is a constant value. The rest mass of the electron, we know that it is 9.1 into 10 to the power minus 31 kg. So this rest mass of the electron will be provided in the question. This data will be provided in the question. So if I put all the datas, then I can find. So first let us put the value of q. Q is 1.6 into 10 to the power minus 19 into tau sc. Tau sc equals to 10 to the power 15 second. Electric field equals to 100 kilovolt per centimeter, and Mn is given by 0.076 into 10 to the power 31 into 9.1 kg. So if I calculate all the data, after calculation we can find that the final value of the drift velocity will be 0.023 into 10 to the power 6 centimeter per second. So this will be the drift velocity of the electron in gallium arsenide. So this is all about the numerical on scattering time and drift velocity. Thank you.